Let's explore how we can analyze some data in Python. What we'll be doing is taking a card transaction data set, and this is a data set that's a Parquet file. Parquet is a very efficient file format. It's much smaller than Excel or CSV, but is also faster, and it's great for analysis. I usually just convert all of my files to Parquet at the start. So let's download this file, and for that I'm going to use curl. So curl minus o, let's call it transactions.parquet, and the format of the file is this. It's basically a variant of the URL with an export equals download that we extract, and the way you get that is by clicking on the download button out here and then seeing what is the exact URL that it downloads. So you can see that it's captured the uh, it's downloading with a particular URL that I managed to copy quickly enough. So that's what's pasted here. Let's run that. Now this is going to download into a file called transactions.parquet, the entire file. Of course, Colab has to first create a runtime instance, so it's doing that, and after having created the runtime, it's downloaded the file. Let's see how large the file is. It's about about 3 MB, but in terms of contents, it's a fairly large file, and let's review that. For this, to read the Parquet file, we are going to use pandas. I'm going to import pandas as PD and create a data frame which is going to use pandas read Parquet, which accepts, among other things, the file name, which is transactions.parquet. And well, I don't want to see just the head, I want to see the whole data frame. So let's run that. Okay, so it's saying there are 100,000 rows and 22 columns. Now, normally in the old days, I would have gone through each of these columns one by one and analyzed them. But these days, I just copy the whole thing. Let me zoom out a bit. Um, copy the whole thing and put it into chat gpt and put in like I have the following data frame, and I want you to explain it to me step by step. Here is the data frame, and it would give me a result. It would just walk through what is the transaction ID, what is the transaction date. So clearly it has details about card transactions, and it has information about each transaction with what is the type of transaction. Was it a chip transaction, a recurring transaction? Was it through a card present channel or a card not present channel? This is the kind of stuff that I wouldn't have been able to figure out just by looking at the data. But there's one other thing that I noticed, which is that not all the columns are visible. There is a dot 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 here in the middle. So we don't really have access to all of the columns. Let's get all of the columns. I'm going to say um, df dot columns and see the full list of columns. Now, given this, let's pass this to ChatGPT again and say, uh, I missed some columns that were in the overview. Here is the full list, and let's see what it says now. Okay, yeah, now it's saying let's add the missing columns and provide a step-by-step explanation. So we have transaction ID, which is the unique ID for each transaction. We have transaction date, which is where it happened, fair. Transaction time, which is the time part of the date, whether it's a recurring transaction, chip transaction, or ECA7. I don't know what ECA7 is. Whether the card was present or not, whether 3D Secure as a method of authentication was used, whether it used tokenization. Okay, not sure what that is. Whether it can be disputed, that is interesting. There are some transactions that cannot be disputed. Whether the outcome was approved or declined, why was it declined, who issued the card, in which country and in which region, whether it was a credit or a debit card, whether it was acquired, that is, the transaction is being done at a merchant whose bank is, say, Bancodo, Brazil or ABS Bank or whatever in whichever country or region, and the jurisdiction, whether it's domestic or cross border. Fair enough. Is this transaction actually disputed? The earlier was whether it was disputable. Is this a fraudulent transaction? And if it was disputed, what was the type of dispute and how much money was transacted? Great. That gives us enough detail to figure out what we can do with this data set. Now, I actually don't want to figure out what useful analysis to do with this data set. That's also something that I'm going to ask ChatGPT, saying something like, what are some useful and interesting analyses that we can do with this data? And I want it to give it the results in an easy to understand format. So create a table uh, with columns, let's say description of analysis that I can use for this, and also tell me how is it useful. Now, I don't want it to come up with vague analyses. I want it to specifically prefer statistical analysis, not machine learning yet, and that, by which I mean pivot tables or maybe correlation, regression, and forecasting, that sort of stuff. Now, yeah, and let's also be clear, rather than machine learning analysis. Now, let's ask it and see what it tells us. Okay, so this is giving us a fairly longish list of the kinds of things that we could do. We could create a pivot table of transaction type by region, and that is useful because it's giving us the most common transaction types in different regions, helping us understand the preferences. Okay, so some regions prefer this kind of transaction, some regions prefer that kind of transaction. Yes, that could be interesting or useful to look at. Or declines by region. Why is it that in certain areas, certain kinds of transactions get declined, certain kinds of transactions get uh, declined less? That can be useful analysis. Having gone through this offline, what I'm going to do is pick a set of analyses by myself. The first that I'm going to pick is an analysis on um, why are transactions declined by region. That's the first cut. Turns out that Pandas has a function, pivot table, which I can apply on a data frame, which is about as powerful and as flexible as Excel's pivot table. The way it works is I can take a data frame and say dot pivot table, pass it an index, which is basically the rows. In this case, I'm going to say acquire a region, and is that spelled correctly? No, there's a capital R here. The second is the columns, which in this case I would pick dispute type. What are the different types of disputes that help us understand why the transaction might be perhaps declined? And the third thing is what are the values that we want to place in each of these cells. So in this case, the transaction ID, and we want to count the transaction IDs. That sounds like a reasonable thing to do. It's also added fill value equals 0. I'm not sure we need that. Maybe we do. Who knows? So this is our data set. Let's take a quick look at what this looks like. And we find that in APAC, there were 382 fraud disputes, 9,672 no disputes, and 497 non-fraud disputes. All right, but that doesn't really help me understand this data set very well. The problem is that I don't really understand the numbers as well as percentages. So let's ask ChatGPT a question. In fact, I just did that a short while ago, which is um, I ran the command which I just ran, and it showed the count of transactions by acquirer region, by dispute type. But I actually want to see the percentage of transactions by type so that the rows add up to 100%. And it provides me some code. Let's try that out. What it's really doing is taking the pivot table and then dividing that pivot table by the sum along a certain axis. Fair enough. So we'll take the pivot table and let's call this acquirer uh, res- decline disputes and see what the acquirer disputes looks like. It seems to be showing the values as a percentage multiplying by 100. I can read the decimals well enough, so maybe I'll use that. No, actually, let it be. This is fine. So what we have is 3.6% fraud disputes in APAC, 3.4% in Canada, 2.8% in CEMEA, that's lower, 3.4, 3.5, 3.6. So clearly CEMEA has a significantly lower fraud dispute than the other regions. The others are hovering between 3.4 to 3.6, but this is 3x lower than that range. Non-fraud disputes, here it's about 4.6, 4.5, 4.7. They all seem to be hovering in the 4.3 to 4.7 range, so not that much of a variation. What about for issuers? For issuers, all we have to do is change wherever we have acquirer to issuer. That includes, in this case, for our reference, the variable names, issuer disputes, and right here again we find CEMEA to be at 3.0, significantly lower than the rest, and also the non-fraud disputes to be significantly lower than the rest. So a clear conclusion here is that fraud disputes are much lower in CEMEA. Non-fraud disputes also, at least from an issuing bank perspective, seem to be lower in CEMEA, and that's something that we can take to the banks and uh, give them useful information about. For our next exercise or analysis, let's do this. Let's see if the transaction amount actually makes a difference to the approval. So specifically, does transaction amount impact approval? To do this, we can use a correlation function that Pandas has. But to do that, we will need a pair of columns. So we'll have one column that indicates numerically whether approval was given to, 0 or 1, and another column which has the transaction amount. So let's ask ChatGPT to create that. So I'm going to say uh, we have, let me see, given a pandas df with columns. Now, what's the name of the column that we had for decision? Uh, decision. Is there? Yeah, there is a decision column. Actually, what does it look like? Mm, df of decision that has values approved or declined. All right. So given a DF with columns decision, and this can be approved or declined, and a column amount, create a DF with columns approved, which is 1 if decision is approved, 0 otherwise, and amount. Let's see what it would do in this case. So it's saying I'll create a new DF, all right. And in this new DF, it will create a copy with these two, and the approved is the decision, apply a lambda, which is 1 if it's approved and 0 if not, and drop the decision column since it's not required. All right, that sounds reasonable. Let's run this code and we'll then look at new DF. That gives us amount and approved as two columns. Perfect. So now let's calculate the correlation between these. New df dot corr. That would just calculate the correlation between every pair of columns that we have. And what I find is a minus, well, a very, very small negative correlation. So if at all, it's saying that the larger the transaction amount, the lesser the likelihood of approval, which intuitively makes sense, but this is too small. So, is this statistically significant? I don't know. Let me ask ChatGPT. Calculate the correlation um, yeah, of these two columns, amount and approval, and then check if it's statistically significant. Now let's see how it would do the statistical significance test. Okay, it's importing the Pearson R function from scipy.stats, all right, and then it's doing all of this stuff that we've already done, and then creating a correlation and a p-value, getting that directly from Pearson R, and it's saying that if the p-value is less than 5%, then the correlation is statistically significant, otherwise not. Okay, let's run the whole thing as it is and put it into the next cell, which gives us the result saying Pearson R is not defined. That is because I didn't copy the entire thing. I should have copied the Pearson R import as well. I'm not copying the pandas import because I already have that. And this says that the p-value is 0.77. Yeah, that's too high for it to be significant. So in short, the transaction amount does not impact the approval. Okay, does something else impact approval? Maybe domestic versus cross border. Does that impact the approval? Let's see. Does the jurisdiction impact approval? And to do that, I guess we'll first start by looking at jurisdiction. Mm, yeah, dot value counts. How many values do we have of each type? Domestic 86,000, cross border 14,000. All right. So what we'll do is just instead of approval, we will have jurisdiction, and we'll try exactly the same thing. Instead of decision, we'll use uh, jurisdiction, and we'll create a new column. Instead of approved, let's maybe call it domestic. And if it's, yeah, except it's spelled something different. uh, Domestic. Fine. So if it's domestic, then our domestic column will be 1, otherwise it will be 0, and then we are running the correlation on exactly the same set of things. Let's see what this gives us. Firstly, you know, it says correlation is not statistically significant, but I'd like to see the new DF to see if we've gotten this right. um, Yeah, domestic 1110. So it does seem to have gotten this right. And the p value is 0.66, slightly better than the transaction amount, but still clearly there is no impact here. All right. So given that the jurisdiction and the uh, what was the earlier one that we did? The amount do not have an impact on the approval. Maybe there are other factors, but an approach is simply to go through each one of these columns, do this analysis, and get the result, which I'll leave that as an exercise for you. Let's try something else. Let's try looking at how has uh, the percentage of disputed transactions changed over time. But to do this, I'd like to see what period we have data for. So we know we have a transaction date, and this transaction date would have a minimum and a maximum. Let's see what those values are. Now we should get two values. Yeah, the first is 14th of January 2024. The second is 20th of January 2024. So these 100,000 transactions are roughly for a week in January 2024. Let's also look at the transaction time in terms of hour of day. So that would be transaction time, and that goes from 0 to uh, midnight practically. Uh, so what we might want to do is look at the approval rates by day and by hour. Specifically, we probably want to create a table where each row is the hour, each column is the day, and the cells are the percentage of approved transactions. Okay, let's ask ChatGPT to do this. So let's say given a pandas DF with, I have timestamp column called transaction date, and yeah, that's a timestamp column, and a string column, which is transaction time. And this is in the format HHMMSS. Is that right? Yeah, it was hour, minute, and second. Uh, let's also mention that there is a string column decision that is approved, and well, if the transaction is approved. Given this, write concise pandas code to create a table. Now, the kind of table that we want is where the rows are the hour of day, columns are the day, and the cells are the percentage of transaction rows where decision is approved. Let's see how it would approach it. Okay, it's giving me a lot of stuff. It's saying I'll take the transaction date, converting it to date time, and then getting the day as the day name, which is Monday, Tuesday, Wednesday, etc., which is perfect. That's what I want. And then get the hour by converting it to date time, and then creating an approved, which is converting the decision into a 1 or a 0, and then creating a pivot table. All right, let's run this and see if we get our results. I haven't printed the pivot table, so let's print that. And this has as percentages for each hour and for each day what is the approval rates. All right, this looks good, but I kind of want to see where it's high and where it's low. So let's ask ChatGPT to plot this as a heat map. So I'm going to say write code use to plot this, maybe using in Python specifically. I won't tell it which library to use as a table grid that is colored, uh, a heat map basically. Now, the lowest values, the lowest approval rates should be in red, the highest in green, and the medium ones in yellow. Yeah, I guess that should be clear enough. Let's see. So it's saying it will use Seaborn and Matplotlib as the libraries. All right, it does all of these conversions and finally creates a figure, an SNS heat map, which is a Seaborn heat map. Okay, let's copy the whole thing and see what it does. Run the entire thing and eventually it should plot. And yeah, it does. So let's zoom out a bit for Friday, Monday, Saturday. Okay, the days are not ordered, but I'm not too fussed about that. I just want to see if there's any kind of pattern here, certain hours in the morning that are relatively low or high, that sort of thing. And there does not appear to be any discernible pattern. Now, at this point, it may strike you as interesting that we saw so many negative results. There's no pattern by day of the week, there's no pattern by hour of day, jurisdiction doesn't seem to make a difference, amount doesn't seem to make a difference, and you would have thought these should have made a difference. Well, the reason is that this is a randomized data set. In real life data sets, you would almost never see such uniform patterns, and real life data sets would show various kinds of skew. So, what are some takeaways from these? First, Pandas is clearly a very versatile data analysis library. Use it as your first choice of programmatic analysis. You really ought to learn Pandas well. The second is that ChatGPT is quite familiar with Pandas and can generate Pandas code rather well. Don't bother writing code. Just ask ChatGPT to write the code and then check if the code works fine.